Okay, good afternoon to everyone. I hope I am audible for all of you. Am I audible?
Audible, Ram sir.
Audible, sir.
Okay. Uh, okay, now we will move to the session. So before getting into today's topic, we will discuss about, we will recap about the previous session content. Okay. So in the previous session, we have introduced what is a combinational logic circuit. Okay. Can you type it in the chat? In case of combinational logic circuit, the output depends on what? The outputs merely depends on what? Can you type it in the chat? In the case of a combination logic circuit, the outputs depends on. Kindly type it in the chat, dear students. Yes, present combination of input or current inputs. Okay. So நமக்கு இப்போ என்ன inputs கொடுக்குறோமோ அதை பேஸ் பண்ணி இருக்கும். With the help of what the combination logic circuits are built? What the combination logic block contains? This combination logic circuits is built up with the help of which component? Yes, basic logic gates. Okay, in general we can say logic gate. Okay, fine. Thank you, Srihari. Then we have discussed about the procedure to design the combinational logic circuit. Okay, so I will recollect it. First step, what we have to do? Identify the number of input and output variables. Then we have to assign variable name for that. Okay, then we have to form the truth table. From the truth table, we have to derive the expression in terms of canonical form. Then we have applied a Karnaugh map or K map. Okay, from the minimized expression, we are implementing the circuit. That's it. These are the procedures we are following. Okay, then we have designed a binary to gray code converter circuit in the previous session. Gray code to binary code also we have designed. Then we have designed half adder. Okay, can you type it in the chat? What is an half adder? How many inputs are there for the half adder? Yes, very good. What are the outputs of half adder? What are the outputs of half adder? Only Srihari is answering. Yes, Sabarish is also answering. See, kindly interact. As it is afternoon session, you people interact more. Okay, then only the class will be very live. Fine, sum and carry. Okay, then we have discussed about full adder circuit. In that case, how many inputs we have? 3 inputs. Okay, the outputs remain same, sum and carry. Fine. Similarly, we have designed half subtractor circuit, then full subtractor circuit. Okay, full subtractor circuit in the previous session we messed up something. Okay, so I will recollect it one more time. Fine. Okay, now I have given you 2 tasks in the previous session. Okay, okay, in the previous session I have given you 2 tasks. The first one is chocolate vending machine manufacturer. Okay, so that it gives chocolate when you give $5 or 3 and 4 $2. The ultimate aim is you must give $5 a minimum to get a chocolate. That is the condition. Okay, have you done? Have you done that? Have you done that? Anybody? Yes, Sabari Shetty typed the answer A plus BC. Very good. Okay, we will look around it. Here we have assigned the variables with a different naming. Okay, how many inputs and outputs we have for this given problem? Kindly type it in the chat. How many inputs and outputs we are having in the given statement? Sabari Shetty answer lende namakku theriyum. 3 input, 1 output. Very good. Okay, so we are having 3 number of inputs and 1 number of output. Okay, fine. Next, we are going to assign the variable like this. $5 க்கு x5 னு அசைன் பண்ணிருக்கேன் வேரியபிள், $3 க்கு x3. See, you can assign any name for your variable. Okay, but it should give some meaning. So x5, 5 indicates $5, 3 indicates $3, 2 indicates $2. That's why I assign like this. Then for output chocolate, I assign the variable as C. Okay, now truth table. Please observe carefully. Okay, so x5, x3, x2 are the inputs as I told earlier. So this portion is our input. Okay, we have told the input, that means x5 must be high or x3 and x2 must be high. Both must be high. Okay. So on the condition I have marked here. I have marked here. See this. So here we are having x3 and x2 and both are there. Okay. So here we are having only x5. Here also we are having only x5. Here also we are having only x5. See here there is no $3 and $2 at the same time. Okay. In the last case we are having both of this. Is it clear for all of you how I marked the 1 as the output? Is it clear for all of you? I have to give 5 rupees as an input to my system. Okay, it may be either $5 or the combination of $3 and $2. Okay, is it clear? Is any doubt with this truth table? Kindly type it in the chat. Kindly type it in the chat if any doubts. Is it clear? Shall we proceed? See, kindly respond, dear students, kindly respond. Okay, fine. So now what we have to do, with this you kindly type the minterms for the given function C. Output function C ke enna minterms varum. Kindly type it in the chat. Kindly type it in the chat. Three, 2, 7. Very good. Okay, so the minterms are 3, 4, 5, 6, and 7. So what about the next step? What about the next step? Next step enna pannumpa? Yes, very good. K-map. So we are going with K-map. I have grouped. Okay. Kindly tell me the answer. Already Sabarish told A plus BC. He told. Okay. Here A means x5, B means x3, and C means x2. I have considered the variables in that way. Okay. So what about the answer for this? For first grouping, we are having only x5. Okay. The second grouping, we are having x3, x2. So it is x5 plus x3, x2. Very good, Srihari. Very good. Okay. So this has to be implemented as a circuit like this. Is it clear? Is it clear? So task 1 purinjida? Task class nama koduthathu? Yes? Yes? Okay. Now we will move to task 2. Task 2 enna sollirkom? Nuclear power plant. Consider nuclear power plant monitoring system is installed. Okay. So in that we are mainly focusing on temperature, pressure, and water level. Okay. An alarm is made to ring under the given condition. What is the condition? Pressure level high or temperature high, water level low, like the previous one. Okay. So how many variables we are having here? How many variables we are having here? 3 variables. Very good. Okay. How many outputs we are having? 1 output. Okay. So we are having temperature, pressure, and water level are the inputs, and the alarm is my output. Okay. So variables I am going to assign. Pressure ku P na assign pandrom, temperature T, water level L. Okay. Then output alarm ku I am assigning A. Fine. So here is the truth table. P is high or T is high and L is low. This is the thing we have given with the statement. It must be like this. You can look here. So here temperature is high. Okay, water level is low. This condition. Okay, here pressure is high. Here also pressure is high. Okay, here pressure is high. At the same time, temperature high, water level low. Fine. In this case, pressure only high. So ஏதோ ஒரு condition நமக்கு R அப்படினா meaning என்ன? Either this one or this combination. ஏதோ ஒன்னு true இருந்துச்சுனா we will put ones at the output. Okay. Here it is wrong. Sorry. This one is 0 only. Sorry, boy. This one is 0. This one is not 1. Okay. So the outputs are, what are the minterms we are having here? What are the minterms we are having here? See, this one is 0, pa. Wrongly it is put as 1. Okay. 2, 4, 5, 6, 7. Okay. 2, 4, 5, 6, 7. Very good. So for this we have to solve the K-map. So kindly find the answer and tell me. How we can group this? And what are the expression we are getting from this? So in that 4, 5, 7, 6 is one group, 2, 6 is another group. Subtractor typed. Very good. Okay. So what about the final expression? Yes, very good. Super. P plus TL bar. Srihari, Priyanka, Colin. Okay. See, only few people are answering. See, if you are interacting more in the class, if you are asking more doubt in the class, then only the class will be very interesting. Otherwise, it is a one-sided class. நான் மட்டுமே பேசிட்டு இருப்பேன், நீங்க ஜஸ்ட் வந்து என்ன பண்றது, வேடிக்கை பார்க்குற மாதிரி ஆயிடும். ஓகே, ஐ appreciate those who are answering. Okay, thank you. Fine. Okay. So P plus T L bar is the final expression. So this is the circuit. Clear? If you want to take a screenshot, then I will move to next slide. So if you want some time to take screenshot, kindly tell me. There I will stop and you can take screenshot. Shall I move to next slide? Slide number 8, 9. Okay. So this is slide number 8. Kindly take a screenshot. Okay, now we will move to 9th slide. This is the 9th slide. Here in the 9th slide, we made one mistake. For the combination 0, 1, 1, the output is not 1, it is 0 only. Okay, because here you can see pressure is low, here temperature is high. At the same time, water is not low. Okay, what we have told, temperature ஜாஸ்தியா இருக்கு, எனக்கு வாட்டரே இல்ல என்னோட பிளான்ட்ல அப்படினா மீனிங் என்ன? Something it should be alarm. Okay, so here the condition is not producing the true output. Okay, fine. Now I will move to, kindly take a screenshot of this circuit. Okay, I will move to next slide. Yes, I will move now. Okay, already we have gone through design of full subtractor. So full subtractor அப்படினா என்ன சொன்னோம், 3 bits at a time we have to subtract. Okay, so 3 inputs, 2 number of output. So the inputs are assigned as x, y and z. Outputs are taken as difference borrow. Okay, D and B. Fine. Kindly take a screenshot. The previous class I have messed up with one slide, so for that I am repeating it again. Kindly take a screenshot. Fine, I will move to the next slide. So this is the truth table and the expression we got in the previous class. Aravindan, mute yourself. Aravindan. Okay, நானே mute பண்ணிட்டேன். Okay, difference, sum of 1, 2, 4, 7, min terms 1, 2, 4, 7. I hope this truth table everyone knows. Okay, so the truth table எப்படி வந்துச்சுன்றதுல previous sessionல நம்ம நிறைய சொல்லியாச்சு. In this session we are going with the expression. Okay, so for difference 1, 2, 4, 7, so it is written like this. Okay, so first term last term z common எடுக்கலாம், second and third z bar we can take common, then x bar y bar plus xy term become x nor of y, then x bar y plus xy bar becomes x xr of y. It will be like this. So x nor of y can be written as x xr of y whole bar. So finally we have a b bar plus a bar b. Okay, this can be written like this. Final expression is x xr y xr z. Okay, so the underline பண்ணிருக்க இந்த term வந்து நமக்கு நல்லா தெரியும். What is this term? Can you type it in the chat? Regarding the half subtractor, okay, what about the difference? Yes, Srihari typed it. It's a half subtractor output. Okay, difference output. Okay, so with that I am going to use the third variable. That's it. Like your full adder, here in full subtractor we are having the XOR operation alone. Okay, for borrow, in the case of borrow 1, 2, 3, 7, so the variable, the expression can be written like this. Here in first and last term we can take the variable z as common, then second and third x bar y we can take it as common. So we will be having the expression like this. So x bar y bar plus xy become x x nor of y. Okay, then z bar plus z become 1. So finally, here also we have some mistake, sorry. So this one is x bar, this one is y. Okay. So finally we are having the expression like this. So here you can notice, what about x bar y in the case of half subtractor? It is the expression of borrow for half subtractor, and this is the expression for difference in the half subtractor. Okay, so with this we can conclude, using half subtractor we can design a full subtractor. Okay, so how many half subtractors we need? To design a full subtractor? Yes, very good. 2 half subtractors are needed. Okay, so this is the final diagram of the full subtractor. Kindly take a screenshot of it. Previous slide venalo screenshot eduthukonga. Wait a minute. So this one is x and this one is y. Okay. Now you take a screenshot of this. Have you taken? Shall I move to next slide? Yes? Okay. Is it clear for all of you? See, the box போட்டு நம்ம காமிச்சிருக்கிறது என்னன்னு பாருங்கப்பா. This portion is half subtractor 1. This portion is another half subtractor. Using 2 half subtractor, I have implemented the full subtractor function. Okay. So here difference என்ன expression கிடைச்சது? X XOR y XOR z. So already from this half subtractor we have the expression x XOR y. Okay. From the third variable z we have taken and we have used one more XOR gate to find x XOR y XOR z. Okay. Similarly, x bar y is already available. To find x XOR y bar dot z. X XOR y is available from the output of the first half adder. Okay. Sorry, half subtractor. So that we have complemented. So x XOR y whole bar, that becomes x XOR y kandupidichachi. Then z alla nama enna pandrom? Again we are performing AND. Then these two terms must be added together. So this is the final circuit of your full subtractor. I hope everyone understand this. Using 2 half subtractor, we can implement a full subtractor. Okay, clear? So உங்களுக்கு எக்ஸாம்ல கேட்டோம் அப்படின்னா என்ன பண்ணலாம் அப்படின்னு பாத்தீங்கன்னா, instead of drawing this circuit, you can just go with blocks. So இங்க உள்ள சர்க்யூட்லாம் எடுத்துட்டு நம்ம என்ன பண்ணலாம், just blocks மட்டும் போட்டுக்கலாம். Okay, I will tell you, I will explain you. So this what I am going to do is, I am going to make it with the color. Wait a minute. Oh, as this is a text, I think we may not fill color. Okay. See, actually this whole box, it should be one half subtractor. Okay, this block, it is another half subtractor. That's what I am saying. Okay, so in exam point of view, if we are asking full subtractor using half subtractor means no need to draw this diagram and all. Just you put a block, that's enough. Okay, fine. Now I will move to next slide. So now in this session we are going to discuss about the binary adder circuit. Okay, binary adder circuit. Fine. So you already know what do you mean by binary addition. Okay, binary addition na நம்ம எப்படி perform பண்ணோம் அப்படின்றது we all know. Okay, I will recollect it one more time. So addition of this binary number produces a result of up to n plus 1 bit binary number. That we have already discussed. So adula n bit is the sum and 1 bit is the carry. Okay, so consider two numbers a and b. Okay, that are n bit number from 0 to n minus 1 bits. Okay, we are going to perform the addition. Fine. Now how we can perform the addition? A0 plus B0 we have to perform first. Correct? A0 plus B0. How many inputs we are going to add here? How many number of bits we are going to add here? Can you type it in the chat? Even though I am performing n bit addition, okay, each bit I am going to add the least bit. How many inputs we are having? 2. Okay, so A0 plus B0 I have to perform. For this, which circuit we can go for? For performing this addition, which circuit I can go for? The ரெண்டு bit add பண்றதுக்கு very good Srigiri, super, half adder. We have to go with half adder circuit. புரிஞ்சுதா எல்லாருக்குமே? Half adder na enna சொன்னோம்? 2 inputs. It is going to have only 2 inputs. It is going to perform the addition of 2 bits. Clear? So we will be getting the output as sum carry. இது எல்லாருக்கும் புரிஞ்சுதா? Is it clear for all of you up to this? Yes? Yes or no? See, A0, B0, I am going to add only 2 inputs. So half adder is enough for me. So the output of the half adder are sum and carry. S0, C1. Like that we have mentioned. Okay. Now my question is, how you will perform the addition of the next bit? A1, B1 mattum add panna poruma? Yes. Very good, Srigiri. We have to use full adder. Why we have to use full adder, Srigiri? Why we have to use full adder? Yes, 3 inputs. Okay. So, உங்களுக்கு full adder na meaning புரிஞ்சுதா? Full adder la 2 inputs are a bits from 2 numbers and the third input is the carry from the previous addition. That's why we are having 3 bit input. Okay, 3 inputs, 3 1 bit inputs. Okay. So, with the help of full adder we can perform this addition. We are getting the sum as S1, carry as C2. Again, what I need for performing the bits A2, B2, C2? One full adder, again one full adder, again one full adder. So with the MSB, we are getting the final carry. So here it is the sum and here it is the carry. Is it clear for all of you? Can you type it in the chat? How many number of half adders and full adders I need to build an n-bit binary number for performing the addition of n-bit binary numbers? Can you type it in the chat? 1 half adder and n minus 1 full adder. Okay. Sabarisati, I asked about n bit. Okay. So 1 half 4 full you told. Okay. Here we are having many bits. அதனால தான் என்ன பண்ணியிருக்கிறோம்? Dotted linesல mention பண்ணியிருக்கிறோம். Here we have mentioned in dotted line. Okay. So don't think we are having only 5 bits. So here we are having many bits. That's why it is mentioned in dotted line. Okay. So what Srihari typed is correct. Sabari Shetty, I appreciate you. Okay. So your answer is almost correct because here I have highlighted only 5 bits. Okay. That means n minus 1 number of full adder and 1 half adder it is required. Okay. Fine. So now we will design a 4 bit. Okay, before that we will go with how to represent this as a block diagram. Okay, so here we are having a half adder. So the half adder na eppadi represent pannalam? This half adder, how I can represent as a block? Like this. 2 inputs, 2 outputs. A, B are the inputs, S and C are the outputs. Okay, 2 inputs A and B, S and C are the outputs. See, this what I said. Okay, this is the block diagram representation. Exam la உங்களுக்கு draw the logic diagram, digital logic diagram or logic circuit of half adder nu keta, you have to draw the circuit. Okay, if simply it is asked to draw the block diagram means you can draw this. Input left hand side la irukku A, B, output are sum and carry. Okay, similarly in the case of full adder it can be represented like this. 3 inputs, 2 outputs. A, B, C are the inputs, S and C naught are the outputs. Okay, is it clear for you? Block diagram na onnum kediyadu. Input output போட்டு the whole logic circuit is enclosed in a square box or rectangular box, whatever it may be. Is it clear for all of you? Okay, block diagram representation புரிஞ்சுக்கணும். Fine. Now, So the full adder A, B, C we are having, sum and carry out we are having. Okay. So for a change, I am going to change the name of this, change the structure of this full adder to design or easily implement a 4-bit binary adder. So next நம்ம 4-bit binary adder நம்ம பார்க்க போறோம். For implementing those circuit, okay, we are just going to rearrange this input and output in some manner. Okay, so we are having the full adder. Inputs are marked in yellow color. So it is mentioned as AI, BI, CI. What I stands for means individual bits. A0, B0, C0, A1, B1, C0, C1. Like that we can assume. Okay, so the outputs are like this. So note down this diagram. So in the particular diagram na enna panna poram, block diagram na enna panna poram, we are going to use it for full adder. Clear? Is it clear? Just na enna pannirken, input outputs arrows mattum na enna pannirken, orient panni vechirukken. That's it. If I used this particular block to design my binary adder, it will be very easy. Okay, that's why I arrange it like this. Is it clear for all of you? See, in the block எப்படி இது மாத்துறோம்னு புரியுதா? Input output மாற போறது இல்ல, கரெக்ட்டா? Same thing. Generally for n bits I am going to add means each bit I am mentioning with I, the letter I. I indicates the bit number. Okay, fine. Now we will design the 4-bit binary adder. Okay, so far நம்ம என்ன டிஸ்கஸ் பண்ணோம்? How to represent the half adder and full adder as a block diagram. Okay, now we are discussing about design of binary adder or ripple carry adder. So note down this. So this is the circuit we are going to design now. Okay, so in the binary adder or ripple carry adder, idhula pathina, what is binary adder? Already we know. Binary adder na enna pa? What is a binary adder? It is just going to be a digital circuit which is used to add n bit numbers. Okay, so a binary adder is a combinational circuit that produces arithmetic sum of 2 n-bit numbers. That's it. Okay, so it consists of n full adders connected in cascade. Okay, so இதுக்கு முன்னாடி நம்ம சொன்னப்ப என்ன சொன்னோம்? n-1 full adder plus half adder னு சொன்னோம். Okay, instead of that half adder we can also use full adder. I will explain you later point of the session. Okay, so n full adder connected in cascade பண்ணோம்னா நமக்கு என்ன கிடைக்கும்? We can get a n-bit binary adder. Clear? Okay, so the output carry of each full adder is connected with the input carry of the next full adder. By that means we are going to connect the circuit. Okay, the addition of 2 n-bit numbers requires n number of full adders. That's what I am repeating again and again. So n-bit number நம்ம add பண்ணோம்னா ரெண்டு காம்பினேஷன் இருக்கு. ஒன்னு என்னது? 1 half adder plus n-1 full adder. The other thing is n full adder. எது எழுதினாலும் correct தான். Okay, fine. Shall I proceed to the design? Is it clear up to this? Any doubt? See, binary adder அப்படின்றது என்னன்னு பார்த்தோம்னா, the first module binary addition நம்ம manually perform பண்ணோம், கரெக்ட்டா? The same thing a circuit is going to perform. Okay, so that circuit only we are going to design. To design that circuit, for adding the LSB bit, half adder is enough. For adding the remaining bits along with the previous carry, we need full adder. So n-1 full adder, 1 half adder we require, or we can use n full adder. Both can be used. Shall we proceed? Okay. Now we are going to design a 4-bit binary adder. So consider two 4-bit binary number A and B. Okay. How will you represent the variables? 4-bit ன்னு சொல்லியாச்சு. அப்ப A க்கு எத்தனை வேரியபிள் இருக்கு, B க்கு எத்தனை வேரியபிள்? How many variables we are going to have for A? How many variables we are going to have for B? Just to go through it, Sabarish. I have told 4-bit binary numbers. Each numbers are 4-bit. Each numbers are 4-bit. 2 4-bit binary number. I am mentioning 2 4-bit binary numbers. Yes, 4, 4. Yes, very good. 4, 4. So let A equal to A3, A2, A1, A2. See, நம்ம binary to gray code conversion பார்க்கறப்ப சொன்னோம், கரெக்ட்டா? 4-bit னா என்ன பண்ணணும்? For representing each binary number, we need 4 bits. Clear? Same here also. Fine. B equal to B3, B2, B1, B0. So how many input variables we are having? Total எத்தனை input variables இருக்குப்பா? ரெண்டு number நம்ம add பண்ண போறோம். ரெண்டுமே 4 bit number. So totally how many input variables I am having now? See, numbers வந்து ரெண்டு. Okay. For A we are having 4 variables. For representing the number B we are having another 4 variables. In total how many variables we are having now? 8 variables. Okay. Is it easy to go with normal approach? Is it easy to go with normal approach to design this circuit? 8 variable வச்சு நம்ம கேம போடலாமா? Up to 6 only it is possible. Yes, Sabris, no. We cannot able to go with normal procedure. So what we are going to use? Here what approach we are going to use is modular approach, modular design approach. Modular design approach. Modular design approach. So modular design approach we are going to use. Okay, modular design approach means how we will perform the addition. The same thing it can be made with the digital logic circuit. Okay, no need to go with truth table or something else. So such thing we call it as modular design. This is one of the advantage of digital electronics. Okay, so in most of the digital electronics, if I am performing 4-bit binary adder, okay, if I am designing a 4-bit binary adder, when I am asked to design 8-bit binary adder, easily we can do it. How we can do it? With the help of 2 4-bit binary adder, I can perform 8-bit binary adder. If I want to perform 16-bit binary adder, I can use 4 4-bit binary adder. Like that we can go for. Okay, is it clear for all of you? Okay, now you will understand what I am saying. So now we are going to use modular design approach. So first least 2 digits என்ன இருக்கும்பா? The 4 bitல least 2 digits என்னன்னு இருக்கு பாருங்க. A ஓட least digit, B ஓட least digit என்னது? Least bit LSB. What are the least LSB value of the number A and B? A0 is for A, B0 is for B. Very good. A0, B0. So A0, B0. To perform this addition, which circuit is enough for me? A0, B0 add பண்றதுக்கு என்ன circuit போறோம்னு சொன்னோம்? Half adder. Very good. So we are having 2 inputs A0, B0. We are having 2 outputs, sum S0 and carry. As it is used to be the ripple value for the next circuit, we are naming it as C1. Okay, A0, B0 add பண்ணோம்னா sum S0, carry வந்து என்ன பண்ணிருக்கேன்? C1 னு மென்ஷன் பண்ணிருக்கேன். Fine. Next என்ன ஆட் பண்ணனும்ப்பா? Next எந்த bits ஆட் பண்ணனும்? Next what bit I have to add? What are the bits I have to add? Very good. A1 and B1. Okay, A1 and B1. A1, B1 மட்டும் ஆட் பண்ணா போதுமா? Is it enough? Yes, very good. We have to also add C1 along with A1, B1. So which circuit we must use now? Half adder or full adder? Yes, very good, Priyanka. Full adder. Okay. Again, sum is S1 and carry is C2. Fine. Next bit A2, B2. Again 3 inputs. Full adder. Okay. S2, C3. Again 3 inputs. Full adder. S3, C4. The final carry we are getting from this, we can name it as C out. நல்லா கவனிங்க, C4 நான் என்ன பண்ணலாம்? We can represent it as C out. Final carry out from the 4-bit adder. Okay, that I am mentioning it as C out. Is it clear for all of you? Is it clear for all of you? Yes or no? Okay. To implement this particular experiment, okay. See, 4-bit binary adder நமக்கு lab experiment இருக்கு. To perform that, we are having one IC name, IC4008. IC4008. That is our experiment number 4. Fourth experiment அதுதான். IC4008. Okay. 4-bit binary adder circuit. It is incorporated in the IC. Okay. அந்த IC யூஸ் பண்ணி நம்ம என்ன பண்ணலாம்? எக்ஸ்பெரிமெண்ட் ஸ்ட்ரைட்டாவே பண்ணலாம். because this much half adder, full adder, இதெல்லாம் நம்ம பண்ணி cascade பண்ணி பண்ணோம்னா the circuit becomes very very big. Clear? So what for our lab purpose we are going to use is IC 4008. நம்ம தியரியில சொல்றது எல்லாமே lab experiment we are going to do. Okay, so note down this circuit. The circuit ஒரு snap எடுத்துக்கோங்கப்பா. So this portion it is sum and this portion is carry. So இப்ப புரிஞ்சுதா? 2 n bit numbers நான் ஆட் பண்ணிருக்கேன். sum எனக்கு எத்தனை கிடைச்சிருக்கு? n bit sum கிடைச்சிருக்கு. 4 bitல கிடைச்சிருக்கு sum and I am having carry as another bit. So 5 bitல என்னோட output இருக்கும். The 4 bits are sum, the other bit is carry. Is it clear for all of you? See, இதுக்கு முன்னாடி procedure for designing combination logic circuit நான் சொன்னது simple circuits you can go with that procedure. இந்த மாதிரி 8 variable 16 variableல வரப்ப நான் என்ன பண்ண முடியாது, k map boolean algebra யூஸ் பண்ண முடியாது. At that time what we have to do, we have to go with modular design approach. Clear? I hope everyone understand this topic. Shall I proceed? Okay, ABC3, ABC2, ABC1. How to represent full adder, lone block, sir? I can't get you, Sabri Sethi. Can you unmute and ask?
Saying 3 full adder, sir. You told we can do in one block. How to do that, sir?
No. What I have told is in the IC 4008, it is available. The whole thing it is available as a block. Wait a minute. I will show you.
Okay.
I will show you. Wait a minute. I will show you. So what I am going to do is I am going to make this whole thing as a single block. Okay. So now it is my 4-bit binary adder. Is it clear now?
Yes, sir.
The whole circuit it is available in the IC. So உள்ள அந்த சர்க்யூட் இருக்கும் கரெக்ட்டா. 4-bit binary adder எதை வச்சு நம்ம பில்ட் பண்ணிருக்கோம்? half adders and full adder கரெக்ட்டா. Again இந்த full adders எதை வச்சு நம்ம பில்ட் பண்ணிருக்கோம்? half adder கரெக்ட்டா. half adder எதை வச்சு பில்ட் பண்ணிருக்கோம்? basic logic gate. Okay, normal logic gates வச்சு தான் நம்ம பெர்ஃபார்ம் பண்ணிருக்கோம். Is it clear? From one to another, block by block we have to design. Okay, that's what we are saying. Digital electronics is having an advantage. The same thing you may not do it with your electronic circuits. Normal analog electronic circuits la neenga idhe mari panna mudiyadhu. Fine, ஒரு block நான் create பண்ணனா that can be used as a component in another project. That's what I am saying. Okay, fine. Now we will move to next slide. So இது ஒரு screenshot மட்டும் எடுத்து வச்சுக்கோங்கப்பா. Kindly take a screenshot of this. I will move to next slide. Shall we proceed? Sir, can we use IC 4008 for more than 4-bit? Yes, Srihari. If you want to perform more than 4-bit addition, you can use 2 IC 4008 IC. Is it clear? Say for example 8-bit data நான் add பண்ணோம் அப்படின்னா என்ன பண்ணலாம்? 2 4008 அந்த IC நம்ம யூஸ் பண்ணோம்னா we can perform it. Okay, this is the example I have told in the very first class. Modular design அப்படின்னு சொல்லி ஒரு advantages போட்டு நம்ம நடத்தணும். When I am teaching the very first session, we have told those advantages. Okay, now இதுல கடைசில என்ன இருக்கு? half adder இருக்கு. Shall we replace that with the full adder? Shall we replace it? Can we replace it? Replace பண்ணலாமா? Anyhow 2 inputs எனக்கு add பண்ணா போறோம். Now I am going to introduce full adder instead of half adder. நல்லா கவனிச்சீங்கன்னா தெரியும். இந்த ஸ்லைடுக்கும் நெக்ஸ்ட் ஸ்லைடுக்கும் டிஃபரன்ஸ் பாருங்க. Here for adding the LSB A0 B0 க்கு நான் என்ன யூஸ் பண்ணிருக்கேன்? half adder I have used. Okay, the next slide carefully listen. Here I have changed it to the full adder. So I am having the third input as C0. Correct? Okay, now you tell me what about the value I have to give in the place of C0, okay, such that it should not disturb by addition. என்ன வேல்யூ கொடுக்கணும்? Very good Srihari Priyanka. We have to give 0. That's it. So இப்போ full adder யூஸ் பண்ற மாதிரி இருந்தா, when I am using 4 full adders to design a 4-bit binary adder, only one thing I have to do. Initial carry. This we call it as initial carry. Okay. The carry input given to the first full adder circuit, we call this one as initial carry. இதை வந்து நம்ம என்ன சொல்ல போறோம் அப்படின்னா initial carry. So இப்போ adder circuit நம்ம just என்ன பண்ணிக்கணும்? Initial carry 0 பண்ணிக்கணும். That's all. This we call it as initial carry. Initial carry. Okay, initial carry. Okay, is it clear for all of you up to this? Kindly take a screenshot. So இது ஒரு screenshot எடுத்துக்கோங்கப்பா. So 4-bit binary adder using 4 full adders அப்படின்னு சொன்னோம்னா the least significant digit add பண்றதுக்கு initial carry என்ன கொடுக்கணும்? We must give 0. That's it. That's what I am trying to say. That's it. Shall I move to next slide? Shall I proceed? Yes. Okay. Now, limitation of ripple carry adder or binary adder. So I have told you there is another name for this 4-bit binary adder circuit that we call it as ripple carry adder. Can you tell me what is ripple carry adder from this diagram? இந்த diagram வச்சு சொல்ல முடியுமா? ripple carry adder அப்படின்னா மீனிங் என்னன்ட்டு? Yes, C1, C2, C3. Very good, Srihari. That means நல்லா ஒரு விஷயம் கவனிக்கணும். When I am giving the inputs A3, B3, A2, B2, A1, B1, A0, B0 and initial carry. இதெல்லாம் first stage input போகுது. கரெக்டா? These are the inputs available at the instant. கரெக்டா? But in the case of the second full adder, FA1, if carry 1 generated, then only it will get this third input. Fine. இதோட output கிடைச்சாதான் இதுக்கு அடுத்த input கிடைக்கும். கரெக்டா? From this only we are getting the input to the next one. From that only finally we are getting the answer like this. So நான் input கொடுத்த உடனே என்னோட output change ஆகாது. It takes some time. So that from first full adder, the carry output must be given as carry in for second full adder. Such, like that it has to continue till the MSB. Clear? It takes some time. Ripple. Okay, the carry is ripple from one full adder to another full adder. Okay, the same word you have heard in the case of your electronic circuits. Electronic circuits rectifier நடத்திட்டாங்களா உங்களுக்கு? Have you studied about rectifier? Intermediate. Srihari told intermediate. That also a correct value. Correct one. Okay, in that rectifier circuit you will be having ripple factor அப்படின்னு சொல்லியிருக்கோம். நீங்க எவ்வளவுதான் AC component filter பண்ணாலும் there may be some AC component available in the final output. That we call it as ripple அப்படின்னு சொல்லுவோம். The same thing இங்க நம்ம என்ன சொல்றோம்? carry எனக்கு வந்துட்டே தான் இருக்கும் from one to another. Okay, fine. Now this response is slower or faster? இந்த circuit ஓட response slower இருக்குமா faster இருக்குமா? As we are having ripple carry, whether the circuit is faster or slower? Slower. Very good. So to overcome this, so ஏன் வந்து இது slower னு சொல்றோம்? Why it is slower? Because the carry in for each full adder is depend on the carry out signal from the previous full adder. Correct? Okay. To overcome this, we are having some adder circuit named fast adder or carry look ahead adder. So like that we are having many circuits. Okay, நம்ம IC 4008 சொன்னோம் இல்லைங்களா? அதுல எதை யூஸ் பண்ணிருக்காங்க அப்படின்னா fast adder circuit they have used. Okay, so நம்ம தியரியில படிக்கிறது ஒண்ணு, அந்த லேப்ல யூஸ் பண்ண போற ஐசியோட டிசைன் வேற. பட் ரெண்டுமே ஒரே ஆபரேஷன் தான் பண்ண போகுது. கிளியர்? So fast adder is not in our syllabus. Carry look ahead adder we are having one topic. If time permits we will see later. Okay, so adu later நம்ம பார்க்கலாம். Next what we are going to do? Binary subtractor. Okay, so binary subtractor means what? Two binary numbers a minus b can be done by performing addition of a with 2's complement of b. Okay, now I will ask you one question. To design the binary subtractor, whether I have to use full subtractor or half subtractor? Yes or no? Whether there is a need? See, 4-bit binary adder na half adder, full adder use பண்ணி நம்ம build பண்றோம். கரெக்ட்டா? 4-bit binary subtractor or n-bit binary subtractor அப்படின்னா நம்ம எந்த component யூஸ் பண்ணணும்? We can go with what? Kindly type it in the chat. Kindly type it in the chat. Okay, full subtractor we can use subrecipe. Fine. Okay, but the thing is, is it possible to implement the operation a minus b using adder circuit itself? Is it possible or not? Srihari, we want OR gate. I can't understand you. See, what I am asking is it possible to perform subtraction in terms of addition? The answer is shown in the slide itself. Yes. Okay. So, the same circuit, okay, we can do little modification so that it will work as a binary subtractor. Are you able to understand what I am saying? Yes, Srihari, using 2's complement addition, we are going to perform. Okay. Now, a minus b is equal to what? A plus 2's complement of b. Correct? See, a minus b using 2's complement addition. Why we have taught? The same thing, it is implemented as a circuit. That's why we taught that. Okay. Now you tell me what are the components we need for performing this. How we can write 2's complement of b? What is 2's complement of b? What is 2's complement of b? 2's complement of b அப்படின்றது என்னதுப்பா? 2's complement of a variable அப்படின்னா first என்ன பண்ணுவோம்? Kindly anyone type it in the chat. What is 2's complement of a number? Very good, Srihari. 1's complement plus 1. So what I am going to do is 1's complement of b plus 1. Okay. 1's complement of b, I am going to represent it as b bar. So a plus b bar, that means a plus 1's complement of b plus 1. Okay. In LSB we have to add plus 1. Very good. Okay. So a plus b bar plus 1. Is it clear for all of you? Is it clear for all of you? Now you tell me what are the components I am in need to perform a minus b. இப்போ additional என்ன component எனக்கு வேணும்? 4-bit binary adder யூஸ் பண்ணி நம்ம பண்ணலாம். கரெக்ட்டா? Additional என்ன ஒரே ஒரு component மட்டும் எனக்கு வேணும். Which component I am in need extra? Very good, Srihari, NOT gate. Okay. So, binary subtractor can be constructed with the help of binary adder with NOT gate. NOT gate எதுக்கு யூஸ் பண்றோம்? To perform the complement operation of the data b. Okay. Now, consider two 4-bit binary numbers a and b. So, now we are discussing about 4-bit binary subtractor. So, two numbers a and b we are having. That a equal to a3, a2, a1, a0, b equal to b3, b2, b1, b0. Okay. To complement the 4-bit binary number, 4 NOT gates are required. Okay. To perform the 4-bit addition operation a plus b bar, we need 4 full adder. Correct? Fine. இது மட்டும் பண்ணா போருமா? What about the another thing we have to do? Okay, Srihari. This slide, take a screenshot. Take a screenshot, Srihari. I will proceed to next slide. Okay. Fine. இது புரிஞ்சுதா உங்களுக்கு? The second number, binary number b நான் complement பண்றதுக்கு எனக்கு என்ன வேணும்? 4 bits we are having. So 4 NOT gates we have to use. Okay. Then to perform the addition of a plus b bar, one 4-bit full adder or 4 full adders are required. Okay, one 4-bit binary adder நான் யூஸ் பண்ணலாம். அப்படி இல்ல என்ன பண்ணலாம்? 4 full adders னு மென்ஷன் பண்ணிருக்கோம். Clear? Fine. Apart from this, we have to do one more thing. Can you type it in the chat? What about the one more thing we have to do? Full adder ஓட initial carry என்ன கொடுக்கணும்? 1 or 0? Srihari, to perform normal addition we can give 0. Okay. Subtractor told is correct. Okay. So carry is one of the input. I am saying the plus 1 is a carry. Is it clear? To perform the operation a plus b bar plus 1. Initial carry input எனக்கு என்ன வேணும்? Initial input carry 1 கொடுக்கணும். அப்ப எனக்கு என்ன கிடைச்சிரும்? a b bar initial carry 1 add ஆனச்சுனா a plus b bar plus 1. Is it clear now? Is it clear now, Srihari? Yes? Okay, fine. Now we will implement the circuit. Okay. So we are having 4-bit binary numbers, two 4-bit binary numbers, A and B. Okay. A as it is we are going to use. What about B? B3, B2, B1, B0. எல்லாத்தையும் என்ன பண்ணணும்? What we have to do? One's complement. What logic gate I have to use? என்ன logic gate நம்ம யூஸ் பண்ணணும்? One's complement எடுக்க? Not gate. Very good. Is it clear up to this? Is it clear up to this? Is it clear up to this? Yes. Okay. Now, first full adder. நல்லா கவனிங்க. First full adder. A0, B0. அது கூடவே நான் என்ன பண்றேன்? I am also giving 1. 1 கொடுத்துட்டா எனக்கு என்ன ஆயிடும்? LSB ல 1 add ஆயிடுமா? A0, B0 is the two inputs from the numbers. And 1 is the value plus 1 for performing plus 1. Initially with LSB I am adding 1. Clear? So now the outputs are S0, C1. Again it is given to the next full adder S1, C2, S2, C3, S3, C4. Okay. So here the S3, S2, S1, S0. இதெல்லாம் எனக்கு என்னதுப்பா? What about this one? This is the difference. Okay, sorry. So this 4 bits are the difference. And what about this one? C4 becomes what? It becomes, wait a minute. Do you remember this? C4 indicates what? C4 எதை indicate பண்ணுப்பா? Look this statement. When I am performing 2's complement addition, okay, if I am getting the carry, you can discard it. Carry வரலனா meaning என்ன? Result வந்து negative. Is it clear? C out or C4, whatever we can use Subtractor. Okay. For understanding purpose only, we are assigning the variable names. So here C4 ne இருக்குது. So here the final carry bit, if it is 0 mean the result is negative. So the meaning என்னப்பா? Final carry எனக்கு 1 வந்துச்சுனா result வந்து எனக்கு என்னது? Positive number. If the result is negative, what we have to do? To know the magnitude, what we have to do? Again you have to perform the 2's complement of the difference. S3, S2, S1, S0 அப்படினு போட்டுக்கோங்களா? So இது வந்து நமக்கு difference னு சொல்லியாச்சு. கரெக்ட்டா? So இந்த difference எனக்கு கிடைச்சிருக்கிறது நெகட்டிவ்ன்றது எப்படி தெரியும்? If C4 is equal to 0. Fine? Okay. Now I will move to next slide. With that we will stop today's topic. Okay. Next slide போலாங்களா? Shall I proceed? Yes. Okay. Now 4-bit adder comes subtractor. Sir, 4-bit binary addition பண்றதுக்கு 4-bit binary adder பார்த்தோம். Okay, with little modification in the binary adder circuit, we have performed 4-bit binary subtractor. Okay. Now what we are asking to design is 4-bit binary adder comes subtractor. What it means? அப்படினா meaning என்னப்பா? அது என்ன சார்? adder comes subtractor. அப்படினா meaning என்ன? 4-bit adder okay, binary adder, 4-bit binary subtractor okay. Here we are having 4-bit binary adder as well as subtractor. What it means? Yes, addition and subtraction can be done in one circuit, okay, with the help of an additional control input. Called select line. So அதுக்கு நான் m னு பேர் கொடுத்துக்கிறேன். என்ன பேர் கொடுத்திருக்கேன்? m னு கொடுத்திருக்கேன். Fine. இந்த m பொறுத்த வரைக்கும் எனக்கு ரெண்டு வேல்யூ இருக்கலாம். either it can be 0 or 1. Okay. எனக்கு 0 இருந்தா ஒரு ஆபரேஷன், 1 இருந்தா இன்னொரு ஆபரேஷன். To select the operation, we are going to use one more variable called m. Is it clear for all of you? We can do both the things in the same circuit by adding additionally a control input named m. Okay, generally we call it a select line. As it is used to select the operation, it is called a select line. Shall we proceed to design? It is an interesting topic. So இது வந்து கொஞ்சம் இன்ட்ரெஸ்டிங்கான டாபிக். Fine. Shall we proceed? Yes. Okay. Now M is used for mode selection. Mode means addition or subtraction. அதை choose பண்றதுக்காக யூஸ் பண்ண போறோம். Fine. Before you are designing any circuit, you have to fix the logic. Now what we are assigning, M 0 இருந்தா என்ன பண்ணணும்ப்பா? If M is equal to 0, what it must perform? It must perform addition. Okay. If M is equal to 1, the same circuit, it has to behave as it has to perform subtraction. Is it clear now? Is it clear now? புரியுதாப்பா நான் சொல்ல வர்றது? Okay. Now next போலாமா? Next. For M equal to 0 condition, binary adder work ஆகணும்னு சொன்னோம். கரெக்ட்டா? It must work as a binary adder. Binary adder னா என்ன பண்ணணும்? You are having two inputs for each full adder. Correcta? ஒன்னு A ன்னு சொன்னோம், இன்னொன்னு B ன்னு சொன்னோம். Correcta? Fine. The 4-bit binary number input. Sorry, here it is A. Sorry, here I made one mistake. Slide number 31. Correct only. Okay, correct only. The 4-bit binary input B must be as it is. B என்ன என்ன பண்ணக்கூடாது? Binary adder na meaning என்னப்பா? B na complement பண்ணக்கூடாது. கரெக்ட்டா? The input B must be as it is. Is it clear? Is it clear? If I am saying a normal adder circuit நம்ம என்ன பண்ணோம்? B அப்படியே கொடுத்துருவோம். கரெக்ட்டா? Initial carry என்ன பண்ணோம்? C0 equal to 0 பண்ணோம். Now you tell me for M equal to 1 condition, binary subtractor அப்படின்னு சொன்னா என்ன பண்ணணும்? பைனரி சப்ட்ராக்டர்னு சொன்னா இதுல என்ன சேஞ்சஸ் பண்ணணும்? போன பாயிண்ட் ரெண்டும் எனக்கு என்ன மாறணும்? ஓகே, கேரி அவுட் இனிஷியல் கேரி C0 அது வந்து கண்டிப்பா 1 இருக்கணும். வெரி குட் சபரி. வாட் அபவுட் another point? What about the data B or the number B? Each bit of B must be complemented. வெறும் டேஷ் மட்டும் போட்டிருக்கீங்க ஸ்ரீஹரி. Very good. So one's complement. Okay, fine. So 4-bit binary number B must be complemented. Complemented in the sense one's complement, it is indicated here. Okay. Initial carry வந்து சபரி சொன்ன மாதிரி C0 is equal to 1. Fine. Fine. Okay. Shall we design? Shall we design? Shall we design? கொஞ்சம் கேர்ஃபுல்லா கவனிங்க இதுக்கு அப்புறம். Okay. Now design consideration. Let each bit of 4-bit binary number B is commonly represented as BI. For easier understanding நான் என்ன பண்ண போறேன்? B0, B1, B2, B3 எல்லாம் கிடையாது. ஜெனரலா BI ன்னு வச்சுக்க போறோம். Clear? Next step. Let YI is the second input of each full adder. Clear? நல்லா கவனிக்கணும். இந்த YI அப்படின்றது என்னன்னு பார்க்கலாம். YI அப்படின்றது என்னன்னு பார்க்கலாம். YI is the second input of each full adder. What it means? Actually, second input full adder க்கு என்ன போகணும்? B0, B1, B2, B3. Correcta? Is it clear? But I am going to implement both adder and subtractor. Correcta? அப்ப meaning என்ன? A modified input is going to be for B. For example, I will draw a diagram here. Okay. You consider this is my full adder 0, FA 0. I am assuming FA 0. Okay, we are having two inputs. One is A. Here, one is A. The other input, it must be given to a black box. The black box தான் நான் டிசைன் பண்ண போறேன். கரெக்ட்டா? இங்க நான் கொடுக்கிற இன்புட் என்னது? BI. ஜெனரலா BI ன்னு வச்சுக்கலாம். Here also I ன்னு மாத்திக்கலாம். FAI. Okay. This also I am changing it as I. Fine. For this black box, I am going to have the input M. Okay. From this, we are going to give initial carry C naught. Okay, then we will be going to have the sum as it is Si. Okay, then the output we are going to have is Ci plus 1. So இது வந்து Ci னு வெச்சுப்போம் காமனா. Is it clear for all of you? இந்த black box இருக்கு இல்லீங்களா, இந்த black box அதை தான் நான் டிசைன் பண்ண போறேன். ஃபைன். இந்த black boxக்கு என்னென்ன இன்புட் கொடுக்குறோம் பாருங்க. என்னோட பைனரி இன்புட் B0, B1, B2, B3 காமனா நான் என்ன எடுத்திருக்கேன் Bi. So that is one input. What about the other input? M is the other input. What about the output? இங்க கிடைக்கிற அவுட்புட் தான் நான் என்ன சொல்றேன் Yi. Is it clear for all of you? Is it clear for all of you? Okay, design பண்றப்ப இது புரியும் உங்களுக்கு. Okay, when I am designing you can clearly understand. As of now Yi அப்படின்றது என்னது? The second input of each full adder. It is from the inputs B and M. Okay, if M equal to 0 then Yi என்ன வரணும் Bi. அதாவது Yi அப்படின்றது என்ன சொல்றோம்? It is the actual input we are going to the give us the second input to the each full adder. Correcta? Clear? I stands for 0, 1, 2, 3 எது வேணா இருக்கலாம் நமக்கு. For example 2 consider பண்ணோம்னா Y2 equal to B2 அப்படின்னா மீனிங் என்ன? If M equal to 0, M வந்து 0 இருந்தா எனக்கு என்ன இருக்கணும்? Yi வந்து Bi க்கு இருக்கணும். அதாவது B வந்து அப்படியே போகணும்னு சொல்றோம். கரெக்டா? அதே if M equal to 1 இருந்தா என்ன சொல்லியிருக்கோம்? B வந்து காம்ப்ளிமெண்ட் ஆகி போகணும். Is it clear for all of you? Yes or no? Yes or no? Yes. Okay. Next. What about the initial carry input C0? M equal to 0 இருந்தா எனக்கு என்ன போகணும்? If M equal to 0 இருந்தா C0 என்ன இருக்கணும்? ஆடர்னு சொல்லியாச்சு. அப்ப என்ன இருக்கணும்? இனிஷியல் கேரி 0. M equal to 1 ன்னு சொன்னா மீனிங் என்ன? இனிஷியல் கேரி 1 கொடுக்கணும். சப்ட்ராக்டர் சர்க்யூட்டுக்கு இனிஷியல் கேரி 1. Is it clear up to this? Is it clear up to this? See, kindly replay. Okay, clear. Now, this screenshot மட்டும் எடுத்துக்கோங்க. I will move to next slide. Kindly take a screenshot. Okay, now truth table. M equal to 0 na எனக்கு என்னது? Yi equal to Bi, C0 equal to 0. கரெக்ட்டா? If M equal to 1 na Yi equal to Bi bar, C0 equal to 1. இந்த கண்டிஷன் புரிஞ்சுதா எல்லாருக்குமே? Up to this condition. Is it clear? Yes or no? Okay, yes. Now, M Bi தான் நம்ம இன்புட்னு சொன்னோம். கரெக்ட்டா? Yi, C0 are the output. இந்த black box நம்ம டிசைன் பண்ண போறோம். நல்லா கவனிங்க. M equal to 0. இந்த கண்டிஷன் ஹைலைட் பண்ணி காமிச்சிருக்கு. நல்லா கவனிங்க. M equal to 0. அப்படின்னா மீனிங் என்ன? இங்க Bi ல என்ன இருக்குதோ அது எனக்கு என்ன இருக்கு? அப்படியே இங்க வந்திருக்கு. Is it clear? Is it clear or not? Yi equal to Bi. அதான சொன்னோம் இங்க. M 0 இருக்கிறப்ப என்ன சொன்னோம்? Yi equal to Bi. அதான் நான் இங்க ஃபில் பண்ணியிருக்கேன். கரெக்டா? அதே மாதிரி C0 என்ன சொன்னோம்? C0 must be 0. அவ்வளவுதான். M 0வா இருந்தா C0 எனக்கு என்ன இருக்கணும்? இந்த ரெண்டு கேஸ்லயும் M 0. So C0 0. Okay, consider this condition. M is equal to 1. அப்ப என்ன இருக்கு பாருங்க? இங்க உள்ள 0 1. Wait a minute. இங்க உள்ள 0 1 எனக்கு என்ன இருக்கு பாருங்க? 0 becomes 1, 1 becomes 0. Complement பண்ணிருக்கமா? What it means? M equal to 1 means Yi equal to Bi bar, C0 is equal to 1. Is it clear for all of you? Is it clear for all of you? Yes. So இது வரைக்கும் எல்லாருக்கும் புரியும்னு நினைக்கிறேன். Up to this truth table. Fine. Now, Yi எப்படி represent பண்ணலாம்? Sum of 1, 2. What about C0? Sum of 2, 3. இதை நம்ம சால்வ் பண்ணோம் அப்படின்னா 1, 2 means M bar dot Bi plus M Bi bar. What about the expression for this? Can you type it in the chat? M bar Bi plus M Bi bar. What about the expression for this? எந்த லாஜிக் கேட் வச்சு இதை பெர்ஃபார்ம் பண்ண முடியும்? XR. வெரி குட் ஜீவிதா சபரிசிட்டி, வெரி குட். ஸோ M XR வித் BI முடிஞ்சு போச்சு. அடுத்து ஸோ அப்போ Y0னா மீனிங் என்ன? M XR வித் B0. Y1னா மீனிங் என்ன? ஜஸ்ட் சப்ஸ்டிட் பண்ணிக்கோங்க, அவ்வளோதான். ஸோ எத்தனை பிட் போனாலும் இதுதான் வரப்போகுது. கிளியர்? நெக்ஸ்ட் C0க்கு என்ன எக்ஸ்பிரஷன் கிடைக்குதுன்னு பார்க்கலாம். M டாட் BI பார் 2க்கு என்ன பண்ணுறோம்? 1 0. ஸோ M BI பார். அடுத்து 3க்கு 1 1. ஸோ M BIன்னு எழுதியாச்சு. M காமனாக எடுத்தோம்னா BI plus BI பார் முடிஞ்சு போச்சு. ஸோ ஃபைனலி we are getting C0 equal to M. ஸோ நோட் டவுன் this 2 எக்ஸ்பிரஷன். இந்த எக்ஸ்பிரஷன் நல்லா நோட் பண்ணி வச்சுக்கோங்க. ஸோ இப்போ மீனிங் என்னப்பா? Y0 அப்படின்றது எனக்கு என்ன கொடுக்கணும்? YI அப்படின்றது என்ன கொடுக்கணும்? A common control input or select line M XR with B0, B1, B2, B3 for individual inputs of the full adder. Second input of the full adder எப்படி இருக்கணும்? M XR with B0, M XR with B1, M XR with B2. It should be like that. Clear? Is it clear for all of you up to this? இது வரைக்கும் புரிஞ்சுதா எல்லாருக்கும்? Yes. Okay. Now we will design the circuit. நல்லா கவனிங்க. A as usual அப்படியே போட்டாச்சு. நெக்ஸ்ட் என்ன பண்ணணும்? All the B inputs B3, B2, B1, B0 it is going to be XR with M and we are having the output as Y0, Y1, Y2, Y3. இது புரிஞ்சுதா எல்லாருக்கும்? Yes or no? Is it clear or not? See, only Sabaris is replying. How can I take it? மீது யாருக்கும் புரியல அப்படின்னு எடுத்துக்கலாமா, இல்ல புரிஞ்சுதுன்னு எடுத்துக்கலாமா? Only Sabaris is replying or some else Jeevita repeatedா இவங்க தான் ரிப்ளை பண்றீங்க. Rizwan, Priyanka. Okay, clear. Now, what about my initial carry? C0 என்ன சொன்ன போன இதுல பாருங்க. What about C0? C0 is equal to what? M. So இப்போ என்ன பண்ணலாம் இந்த ஸ்டெப்புக்கு அப்புறம்? இந்த C0க்கு நான் என்ன பண்ணலாம்? I can connect M. நல்லா கவனிங்க. I am connecting M with C0. So C0 is equal to M. அப்போ டைரக்டா M C0 என்ன பண்றேன்? M ஓட கனெக்ட் பண்ணிட்டேன். Remaining thing we are doing as it is. So this is the final circuit. Is it clear? நல்லா கவனிக்கணும்ப்பா. இந்த இன்புட் M எதுக்கு யூஸ் பண்றோம்? What about the purpose of this input M? What it is going to decide? What is the purpose of M here? Subtractor or adder? When the circuit will work as a subtractor? When the circuit will work as a subtractor? Sabari Seti, kindly check. Sub means 0, add means 1. Reverse ஆ போட்டிருக்கீங்கன்னு நினைக்கிறேன். Fine. Correct பண்ணிக்கோங்க Sabari. Priyanka, correct. Subtractor means M is equal to 1. Okay. Adder means M is equal to 0. Fine. See, உங்களுக்கு ஃப்ரீ டைம் கிடைக்கிறப்ப இந்த சர்க்யூட்லாம் நீங்க என்ன பண்ணலாம்? உங்களோட அந்த சாஃப்ட்வேர்ல ஒர்க் பண்ணி பார்க்கலாம். மொபைல்ல சொன்னோம் இல்லைங்களா? லாஜிக் சர்க்யூட் சிமுலேட்டர் ப்ரோ ஆப். In that you can work it out. Okay. So with this we will stop today's session. Okay. இதுலயும் ஒரு note while M equal to 1, if carry bit C4 is 0, then result is negative. Subtractor அப்படின்னு சொல்றப்ப C4 0 வந்துச்சுன்னா negative number னு அர்த்தம். Okay, so with this we will stop. Okay, now we will move on to the lab session. Kindly take a screenshot. Kindly take a screenshot. Wait a minute. So kindly take a screenshot of this circuit. Okay, we will move to next lab session. Is my slide is visible?
Yes, Ram sir.
Yes, Ram sir.
Okay, okay. For me it is not visible, that's why I asked. Okay, kindly take a screenshot of this. Okay, with this we will stop the theory session. Okay, so another 45 minutes we are going to spend for laboratory. Okay. So I will stop the recording.